Hi, I'm Dr. Patty Ferris. I'm a board-certified dermatologist, and I'm your host for this episode of Skincare Confidential. Dr. Ted Lane and I started the podcast as an outreach of our medical meeting, the Science of Skincare Summit, so we could bring educational information about skincare products to a wider audience. The summit will be held in Austin, Texas this year, September 22nd through the 23rd. It's coming upon us. We're 6 weeks out. I'm not sure this episode will air before the summit, but I hope that it will. I'm really excited today to have one of my very esteemed colleagues, Dr. Henry Lim, with me. His bio is pretty extensive here, but I'm going to hit the high points. He is the former Clarence S. Livingood Chair and Chairman of the Department of Dermatology at Henry Ford Health Hospital in Detroit, Michigan. And you held that position for 20 years, Henry, from 1997 to 2017. He received his medical degree from SUNY Downstate and completed his dermatology residency at NYU. He is a past president of the American Academy of Dermatology, the American Board of Dermatology, the American Dermatologic Association, the American Society for Photobiology, and the International Union of Photobiology. That's exhausting, Henry. He was elected in 2019 as a board member of the International League of Dermatological Societies, and now I think you've taken the presidency of that organization, so you'll have yet another presidency under your belt. He was awarded an honorary membership, which is a very high honor from the American Academy of Dermatology in 2020. You have a long list of accolades here, and I'm just going to tell everybody that they're impressive, but they would take me a long time to read. He's published more than 570 articles, edited 11 textbooks. You're going to have to tell me how you get people to submit their chapters, because that's the challenge of editing a textbook, right?
Absolutely.
And he has also been voted by Expertscape as the world's top-rated sunscreen expert. So no surprise that today I'm going to talk to Dr. Lim about sunscreen, about photoprotection. And Henry, I'd love to start these episodes, especially with friends and people I know like you, but I don't really know the answer to this question. How did you get interested in photobiology?
Patty, that is a very, very good question. First of all, thank you very much for inviting me to participate in this podcast. You know, we have known each other for a long time. You are one of my favorite persons for sure.
Thank you.
Definitely is a pleasure to be on the screen with you here. So coming back to your question about photobiology, actually is by chance, really. You know, I have never planned my career path very, very clearly from the very beginning. All I knew was that when I was in residency, I wanted to be in academic dermatology. Primarily, I liked the intellectual stimulation. So I was asked by my chair at the time, Rudy Bear, whom you probably know, he passed away, of course, but you know Dr. Bear. So he said, well, you know, go work in the laboratory because at that time he wanted to be an academician. You know, having spent time in the laboratory is definitely one of the paths to get there. So it happened to be that the laboratory that I worked in, which is led by Irma Gili, who became the chief of dermatology at UC San Diego, had a project on the activation of the complement system. Again, keeping in mind this was in the 70s, so the complement system was quite a hot topic of research at the time. The activation of the complement system by porphyrin and light. So that's how I got started in the laboratory, and then I expanded from there to seeing patients with porphyria, and then at NYU, as I established the photodermatology unit. I worked with Nick Soder in phototherapy unit, and then subsequent to that, I get more interested into not only photodermatology, photodermatosis, phototherapy, but expanded into photoprotection. So that's how, long story, but in a short 3 minutes, that's how the synopsis of my interest in photodermatology.
That's so interesting. And you're right. It's like you don't plan it, but it's those interesting twists and turns of your career that take you in certain directions. Let's start with sort of simple sunscreen and maybe starting with UV protection. I want to go on to visible light and other wavelengths because I know you're an expert in that as well. But really for our audience, some just sort of basics on sunscreen and UV protection and all the different filters that are out there and sort of what's new and what's happening in that arena.
Well, I think the part, speaking to the very sophisticated audience of dermatologists and other healthcare providers on this podcast here, we know that sunscreen is one of the components of photoprotection. Sunscreen was designed and is still a very, very good photoprotector for UVA and UVB spectrum. UVB is reflected by a sun protection factor because that testing primarily is looking at UV-induced erythema, which is primarily the effect of UVB, a little bit of the effect of UVA2, the shorter wavelength UVA. But primarily is the effect of UVB. So the SPF reflects the protection primarily against erythema, which is UVB. On the other hand, the FDA now requires the broad spectrum classification of sunscreen or labeling of sunscreen. So broad spectrum covers essentially the UVA spectrum because we do know UVA acts synergistically with UVB and many of the photobiologic effect of UV, including photocarcinogenesis. But as importantly, UVA also is the main spectrum that induces photoaging changes, but also the photo-induced pigmentation, pigmentary alteration on the skin. So that is how the sunscreen was developed. I mentioned before that sunscreen is just one of the important component of photoprotection. Clearly, we all know photoprotection includes, behavioral modification when we go outdoor, stay in the shade, and then wearing a white brim hat, clothing, and sunglasses. And sunscreen should be applied on otherwise exposed sites.
So, talk a little bit about some of the filters. I mean, we've seen, I think, what we might call a backlash against the bad chemical sunscreens. They've been vilified so much in the press. And now people are really moving more into the mineral sunscreens or the inorganic sunscreens. And I guess you and I've been around long enough to remember when they used to be worried about the nanoparticles that were in the mineral sunscreens. So where do we kind of stand with all of those right now, the ingredients?
The ingredients, and as you all know, that the sunscreen ingredient in the US is regulated by the FDA as an over-the-counter drugs. So it is classified into two broad categories that you, Patty, had mentioned. That in one side is the so-called chemical, also known as organic filters. Those are the vast majority of the filters. And then the other one is the mineral or inorganic filter. You also sometimes it's called also physical sunscreen. So those are the titanium dioxide and zinc oxide. The only two of them that is used by the FDA. FDA classification is that both of them are completely safe. So they have no question about the use and the use and also the marketing of the mineral sunscreen. What FDA has been asking the industry to look at is the mineral sunscreen. There's a group of mineral sunscreen that FDA felt there is just not enough data in terms of the safety, not so much in the efficacy, but in terms of the safety. So they wanted to get more data on that, primarily because of the newer data showing that there is absorption of UV filters, organic filters, into the bloodstream. That's the reason the question has been asked. Having said that, FDA currently still stand behind not only the efficacy, but the safety of all the UV filters. That's the reason there's no sunscreen that has been pulled from the market. But clearly there's FDA is still negotiating and discussing with the industry specifically what type of UV testing that needs to be done in order to be able to satisfy the FDA requirement on this particular aspect. That's where the controversy come in. That is the reason that, Patty, as you have mentioned, many of the public has moved on to using mineral sunscreen. Mm-hmm. So let me mention about mineral sunscreen. Mineral sunscreen nowadays, it is used as nanoparticles, meaning the particle size is less than 100 nanometers. The reason it is used as a nanoparticle is that because it would increase the cosmetic acceptance of the sunscreen, because it makes it less chalky and less white. Because if the particle get larger, then it reflects more of the visible light into our retina. So our retina would then pick it up as a whitish discoloration on the skin. Right. With nanoparticles, then there's less of that reflection of the visible light. That's the reason it is used primarily as nanoparticle. Based on the current data, nanoparticles actually is very, very safe. There is practically no absorption at all into the skin beyond the epidermis, which is where you want the sunscreen to be. So it is definitely very safe. There are some drawback, of course. No matter how fine the nanoparticles are, there's still sometimes a little bit of whitish discoloration. Even though I must say that the industry has done a great job. Now there are many mineral sunscreen. They are very, very elegant. That is almost transparent.
I agree. They've come out with some really beautiful mineral
Yeah.
sunscreens in the last year or two. Talk for a minute about the environmental dangers of chemical sunscreen. I've heard you eloquently discuss it on the podium, and I think in a way that many people can't.
Yeah, it is. It is the sort of the rationale on this is there too. One, the one that I mentioned before, that there is evidence of absorption of organic sunscreen into the skin, resulting in questions about the health effect. But in terms of the environmental effect, is primarily based on in vitro studies, laboratory studies. What had been shown is that if you put corals in a laboratory setting and put UV filters in there, there is an increased probability of coral reef bleaching by measures
Right.
that they use in a laboratory setting. So that had generated a lot of discussion as to, we do know there are bleaching of coral reefs in many parts of the world. The question is that what is the role of UV filters? And what has been studied now is that one, there have been a number of studies to look at the concentration of UV filters in actual seawater, specifically in areas that there are a lot of tourists. For example, one of the study was done in Hawaii. What they found is that indeed you can detect UV filters in the seawater, but the important part is that the concentration is significantly less, a thousandfold less than what is used in the laboratory setting.
Oh, a
So
thousandfold?
that is something that I think we need to keep in mind.
Mm-hmm.
As we know, many of the quote unquote in vitro studies for whatever it is,
Yeah.
it is a big jump to convert it into in vivo clinical setting. So there's something that we need to keep in mind about that. Number two is that we do know that sunscreen or UV filters from sunscreen is just one of the sources of UV filter in the water, because wastewater removal is one. It's a lot of the UV filters is used in the industry to prevent fading of the furniture paint and so on and so forth. So there are other sources in the seawater of the UV filters. Thirdly, there are a lot of studies now to show that actually the major cause of coral reef bleaching is not so much of the UV filters, but the major cause is the ocean warming. The warming of the ocean water causes obviously the coral reef, which is very, very delicate being, to be bleached. So they are multifactorial. In fact, because of this controversy, EAD and many organizations had asked the EPA to look into that, and EPA subsequently had asked the national academies, the independent body, to look at this particular issue. They spent about a good 6 months, about a good 8 months, I think, to look at it with individuals, dermatologists, but also a lot of other scientists to look at this particular issue. All of them have been vetted very carefully for being non-conflicted in scientists and individuals. And essentially what they found is that more studies needs to be done, because
Mm-hmm.
they acknowledge the very complexity of the factors, the different factors that is in there. And there is no standardized method, for example, to measure many of the endpoints that is to be done. So their bottom line is that essentially, based on what their review is, more studies needs to be done.
Isn't that always the way?
It is.
Unfortunately,
Yes.
another big scare we had, I think it was last summer or the summer before, was the benzene that was found in some sunscreens. So maybe
Yeah.
you could speak to that. We're going to get all the
Yes.
bad things out of the way.
Yeah, yeah, indeed, that was a concern, of course, because benzene is known as a carcinogen. That was apparently a supply chain issue, and because of that, actually, there was some sunscreen product that was pulled from the market because of this concern about contamination of benzene. But to my knowledge, everything is now resolved. The industry had to act very aggressively, and correctly so, to make sure that that doesn't happen, and that had pretty much been resolved on that part.
Interesting. So let's move on a little bit to visible light, because I know you've done a lot of work in this area, and it's getting a lot of attention among dermatologists. We didn't talk about visible light not all that long ago, and now we're talking about visible light and even beyond with infrared. So tell us a little bit about visible light. We all know we get visible light from sun exposure, but also from devices. So
Yeah.
how does that all influence our skin and skin
Yeah.
biology?
You're absolutely correct, Patty, that the visible light has been around for a long time. And for the long, actually, we all need visible light for to live, right? And what has been understood for the longest time is that visible light is biologically inert. However, in the past 10, 12 years or so, our group as well as others had shown that indeed visible light has biologic effect. Our group was one of the first that showed that using visible light, exposing visible light on the skin of darker skin individual would result in fairly significant and very intense pigmentation that is longer lasting as compared to the pigmentation induced by UVA, because we know UVA
Mm-hmm.
classically is considered to be the spectrum that would induce pigmentary alterations, and that is the case. But what we've shown is that visible light is even more intense in terms of the pigmentation and also would last longer. So the clinical implications, there are several folds though. One is that clearly, and this only occurs in darker skin individual. When the study was done using skin type 2 individual, skin type 2 subject, nothing happened. There is no pigmentary alteration
Right.
occurred. So the implications on that is that obviously, we know that a lot of the pigmentary alterations occurs in darker skin individual. Clinically, we know melasma, for example, tends to occur in darker skin individual. Post-inflammatory hyperpigmentation, likewise. So there is a clinical implication that we all know clinically. We know with a lot of our patients with melasma, they say, well, doc, I put on my sunscreen all the time, but my melasma continue to get darker in the summertime, and it is possibly the role of the additional role of visible light in addition to UV that is causing that darkening of the melasma. The other implication on that is that in terms of photoprotection, because we mentioned before that currently sunscreen, specifically the UV filters that is approved by the FDA in the sunscreen, is meant to protect against UV, UVB, or
Mm-hmm.
UVA, but it's
Right.
not meant to protect against visible light, because in
Right.
order to protect against visible light, at least on topical level, it has to be visible, because visible light is visible, right? So unless you have something that is visible that would reflect the visible light
Right.
back to our retina, you are not going to be able to protect well against visible light. So there comes the challenge.
Right.
Fortunately, there are now new developments that helps to protect against visible light, and but so it is an active area of research and investigation.
It's a challenge for
It is,
sure.
yes,
Talk a little bit about antioxidants. I know you recently published some things
yeah,
on papers on using antioxidants
yeah,
with sunscreens or sunscreens that contain antioxidants and how that plays into visible light
yeah.
protection in particular.
Yeah, yeah. So the protection against visible light, either topical, and I'll come back to the topical aspect of the visible light protection. There are some new developments on that, but the other way is that through antioxidants, because we do know, just like UV, visible light can induce production of reactive oxygen
Mm-hmm.
species. Clearly, when we studied based on UVA, UVB, and visible light, but in real life, when you go outside, and there's always sort of crossover between UV and visible light. So reactive oxygen species likewise is generated definitely by UVA, but also by visible light. So the rationale of using topical antioxidants is that by having antioxidants, it would help to downregulate the effect of visible light. Indeed, the studies that you have mentioned that we have done show that indeed, if the products contain biologically active antioxidants, it can downregulate. It would not completely suppress, but it would help to downregulate visible light-induced pigmentary alteration in darker skin individuals. So that is one aspect that we could use to help to protect the pigmentary alteration induced by visible light. I must say also that industry has developed quite well in terms of biologically active antioxidants, because you probably remember probably about 10 years ago, there's been a study to show that a lot of the topical antioxidant is
Mm-hmm.
not biologically active, but
Yep.
nowadays I think the technology has advanced. Most of the antioxidants in sunscreen is biologically active. So that's one aspect. The other aspect in terms of protection of visible light, is to use tinted sunscreen. So tinted sunscreen is essentially a sunscreen that contains iron oxides, which comes in 3 different colors, and usually the manufacturer would mix and match that. Sometimes they put the non-pigmentary, non-anodized, so pigmentary titanium dioxide also to again mix and match the color. And because they're colored, because of that, it would help to protect against visible light. Clearly, the limiting factor is that, as we all know, you have to tell the patient, get several samples to see which one would match with your natural skin tone so that it would be acceptable for the patient to use. The other limiting factor with tinted sunscreen, obviously, it does, just like tinted makeup, it does sort of color your clothing, so you have to be
Right.
careful about that. In Europe, there are two new filters that protect against the visible light range. One is not so much an invisible light, but in a very long wave UVA, which we know that it would induce pigmentary alteration. So that is the Maxtrail 400. That is a L'Oreal product. It covers essentially the very long spectrum of UVA1, so from 360 to 380, even to 390
Hmm.
range. So it is quite good in helping to suppress the pigmentary alteration on the skin. Another one, which is a PFR product, Triabsorb, and both of them are marketed in Europe and available in Europe. The Triabsorb, is a broad spectrum, so it covers UVB, UVA, but also this one covered visible light spectrum. But because of that particular one is pigmented, so they have to match it with the different type of pigments to make sure that it is acceptable to patients. So those are the development that had occurred, at least for protection against visible light. Two of the products are now available in Europe. A third one is being developed and probably is going to be available in Europe fairly soon.
This is why dermatologists are bringing sunscreen back every time they go to Europe, because they have such great
Yes,
filters there that we don't have.
correct. Yes,
Unfortunately, I
yeah,
wish we could get some of these into
yeah,
the States. This would make a big difference. Talk for just a minute about infrared, because that's our sort of longer wavelength of light beyond visible.
yeah.
And I think, again, it's being implicated in photoaging for sure.
Yes, yes. We just published a review paper actually on this particular aspect in photodermatology, photoimmunology, photo medicine journal. But essentially, you're absolutely right. Infrared. We all I think recognize infrared being the source of when you go outside to get the heat from sunlight. That is the effect of infrared, right? But the one that is most biologically relevant is the infrared A, which just happen to be the shortest
Right.
wavelength of infrared. And it is indeed has been shown to induce photoaging changes. Initially, was done way back by in animal models, but definitely I think is now known also in human. It can induce photoaging changes. But infrared is an interesting spectrum because depending on the dose, depending on the amount that is exposed, that the skin is exposed to, they are beneficial effect. Even though
Mm-hmm.
the beneficial effect of infrared, there have been a lot of studies on that. The data is not yet quite strong, but the indication, the signals there. We all know that infrared has been used for the treatment of various type of hair loss, for example.
Yes.
Those various caps, right? There are studies on that. Most of the studies are sponsored by industry, but nonetheless, there are some data on that. It is used also for wound healing. A
Mm-hmm.
lot of leg ulcers, for example, the infrared, they have that data to show that it can be helpful for wound healing. Sometimes it is used even for sclerodermoid skin changes. Again, it seems to be depending on what dose you use. Clearly, more studies needs to be done, but I think there are quite a bit of signal to show that this is quite potentially could be very helpful. So I think this is
So
another
it's a double
exciting
edged
area.
sword, a little
Yes,
bit of a double edged sword at this
it
point.
is. It is. Yes.
Maybe just in closing, speak for just a minute about some of the other exposomal factors, maybe pollution and some of the other things that we also now know are contributors to
Yeah,
not sun
that is
damage,
an
but skin damage and environmental damage.
Absolutely. That is another new area, relatively new area within photobiology, within photoprotection. Pollutants is a significant factor. There are some suggestions that, when you are living in a highly polluted environment, the
Hmm.
photoaging changes would be more accelerated. Again,
Yep.
there are a lot of data, but still not more studies again needs to be done. But I think something that we should continue to watch out for. The other one new area in this is microbiome, the skin
Yes.
microbiome. Again, there's a lot of studies now. There is a trickier one to study because it is a lot of study has been done with gut microbiome, but now the skin microbiome is being studied. The challenge with microbiome is that because each one of us has different microbiome, even on different parts of the body, the population of microbiome is very, very different. So we need to continue to be able to standardize and come with a conclusion that microbiome is helpful or hurtful. There are some suggestion that some microbiome is photoprotective. It serves as a photoprotective mechanism. But at this moment, I think it's still relatively early, but there are a lot of new data coming out on that.
So interesting. We've come a long way, haven't we?
Yes, we
So
have.
many
We have.
developments. I'm
We have.
going to wrap it up here, and I'm so appreciative of your time and your expertise and for you joining us today on the podcast. Thank you for everything, Henry, and all your contributions to dermatology and to the world of photobiology. I'll keep reading your articles and attending your lectures and hopefully learning more.
Thank you very much, Patty, for having me. Thank you for the kind words, and it's a pleasure to continue to work with you.